We don't know the angle yet. But we do know the time, we do know how far it went in x. Okay, so we can figure out how high up it went because we still have our 1/2 a delta t squared, which is just 1/2 times 9.8 times 3 seconds squared. Okay, and we have, what is it, 1/2 times 9.8 times 3 squared, which is 9. So it went up No, that's not what it means, Quentin. It means that it ends. That means one of them is 0, either the top or the bottom. It works out the same way. So 44.1. Because since we know that the thing has been thrown upwards, it's going to slow to a stop at the very top. This equation works whether the first or the end is 0. It works the same. So the ball rises 44.1 meters into the sky. So 44.1 meters. Okay, so there we go. We have that. Now, and we know our time. So knowing our time, we can actually figure out what our initial velocity was in the y direction, right? Because our delta v is equal to vf minus v0, which is equal to a delta t. And just like I said, throwing the ball straight up, our final velocity is 0. So negative whatever our initial velocity was is equal to negative 9.8 multiplied by our 3 seconds. Which means that our initial velocity is negative 9.8 times 3, and then cancel out both those negatives, and that our original velocity was 29.4. Our original vertical velocity was 29.4 meters per second straight up. Okay, that's what that means. And we know that this is equal to this too. So we're getting close. We're working it out. Okay. Now we also know that our delta x is equal to our vx delta t, right? And we know our delta x, which is 20, equals whatever our vx is multiplied by 3 seconds. So our vx is just 20 divided by 3, or 6.6 repeating meters per second. Okay, so now we're searching for our v and our angle. And now what we have is, we have an x that's 6.6, and we have a y which is 29.4. We are looking for this and this. Okay, so what we have up here is our system of equations. Okay, so we have 29.4 equals v sine of theta, and we're going to divide that whole thing by 6 2/3, which equals v times the cosine of theta. Okay, and you should recognize this right here as the tangent, of that angle, right? These cancel out, and what we have is the tangent of theta equals 29 divided by 6 2/3. Or 4.41. And if we take the antitangent, tan to the -1 of both sides, our angle is 77.2 degrees. 77.2 degrees. Okay, so that's our angle. And now we can just plug that angle into either one of these things to get it. What is that, and is that needed? What do you mean? What is what? What is what, and is what needed? So I said at the beginning of the problem, that we are looking for the angle. So yeah, the angle is needed. Theta is just x, but for angles. So let's go ahead and plug in either one of these things. Theta is just an unknown angle. It's just like x, but for angles. So now we know this, we can plug this in. So let's just pick this one right here. Vy, or 29.4, equals whatever V is, multiplied by the sine of 77.2 degrees. And if we divide both sides by the sine of 77.2 degrees, we end up with a V of, okay, sine of that, 29.4 divided by that. Hello, Merkadsizen. Hello. Anyway, so we end up with initial velocity of 30.15 meters per second. That's what we end up with.